Hi guys, welcome back to the channel. My name is Kira and today I want to talk about my orange pie again. So I did some experiments on my orange pie, and if you had watched my last video you would remember that I had mentioned that my mining speed was 90 seconds for an 8 terabyte hard drive. Since then I've been able to get it down to 72 seconds, and I wanted to share with you about how I did that. The other thing that I'd like to do today is to run a couple of experiments using hard drives that have been formatted using a different allocation unit size. The drives that I typically use for my mining have a 4 kilobyte allocation unit size, and I've got a couple of drives here, right here, and they've been formatted with a 16 and also a 64 unit allocation size. And I've heard of people playing around with those to see if they can increase the speed or something like that. I'm not really sure what's going to happen, but we're going to find out. So I've loaded 1 terabyte files onto both of these drives, and we're going to see if there's any speed difference between them. So one of the problems with Orange Pi is that it doesn't dissipate heat quickly enough, and then it starts to heat throttle and then things slow down. And so what I've done is I have created a monster, and I have rigged a little blower fan onto the CPU, and I put a zip tie around it, and it's kind of funny looking, but it works pretty good. The system doesn't heat throttle anymore. Underneath the blower here, I've got a aluminum heatsink, and I'll put a link in the description. There's also copper ones. I just happen to have this one, and it's definitely brought the temperature down. Without the heat sinks or anything like that, during the mining process, the CPU will hit like 70 degrees Celsius. And now it's staying nice and cool, and I'm going to show you guys the numbers, what this thing does, and we'll go from there. So the cooling fan is plugged into the GPIO. I'm borrowing the ground and the positive 5 volts at the very end of the GPIO near the Ethernet. So this is a 12 volt fan, but it's enough. It's totally enough power to do what I need it to do, and it keeps it nice and cool. So we'll go ahead and plug it in. Here is my hard drive that I'm mining with. This is the regular hard drive, so plugging it in, everything should be pretty straightforward. This is a Seagate expansion 8 terabyte. It's my standard drive. There won't be any funny business with this one because I already know it works. And oh yes, that sound of that hard drive. Okay, so I don't know, I can just like lay there. Don't die on me, okay? All right, fine, be that way. All right, okay, so let's go ahead and mount this device. So we are mounted and ready to go, and we're gonna go ahead and run. And let's run our miner and see what we can do. Okay, so that took me a little longer than I had hoped. I put the wrong mining information into the config, and it was like, where are the blocks? So that round finished in 72 seconds. We definitely have a pretty good speed improvement over my original tests. They were coming in at 90 seconds, and yeah, so I'll show you a little bit about how I did that. One was the monstrosity that I added to the Pi, and that definitely brings the temperatures down. If we go ahead and look at the ambient monitor, we get our temperature output. So we've got at our baseline here, we've got about 35-36 degrees Celsius. And I'm going to rerun our block since we don't have a block right now. And you can see how the temperature shoots up. So see, it just went up 12 degrees there. And then if you look over on the left-hand side near the bottom, you'll see the current operating cycles per second of the processor. And we are holding at 1200 megahertz, and that's what we want. If I was to take off the fan, which I'll do right now, so I'm going to unplug my fan. Still a heat sink on there, but I think this will be a good enough demonstration to show the temperature going up and seeing the heat throttling come in. So we're already at 60 degrees Celsius, almost 62 here. Go, go, go! Go, Mark! We'll wait for it. Wait for it. 65. Oh, there we go. So you see, it bumped the clock down to 11:04. Just by adding this fan on, I'm going to go ahead and restart the miner here. See, it's dropping it down. It's only at 1,000 there for a sec. Okay, I'm going to drop this and I'm going to kill this process here. Rerun. We're going to make this thing earn its daily bread. So you're seeing it's throttling right now. Okay, so let's plug in our fan. And I can feel the board is getting warm. It is really toasty. We should see the temperature begin to stabilize here. Dun, da, da, there you go. 1200 megahertz. Oh, it dropped back down in. Hey, computer, stop. I'm doing a video. My fan is on though, so. But it is bringing the temperature down, you see that? And it's keeping it from throttling itself. So yeah, go figure. You just have to jerry-rig a thing and plug it into the board at the voltage that it wasn't designed for, and it works great. So anyways, I couldn't find a blower to this exact specification on Amazon, but there were some similar ones. So I'll try to put a link to a similar one in the description. The hardest part was finding one that was the right size. But anyways, I'll do my best and I'll let you guys know in the description otherwise if I have failed to find one. We've got our good baseline. You can see how from the previous, before I unplugged everything, you know, we were hitting that 72 seconds. And that is a massive improvement over the 90 seconds that I was originally getting. Part of it is definitely due to the fact that I'm using a newer version of the Armbian. And I have a feeling that the company that makes these chips, the CPU in particular, and the Orange Pi maybe, they've fixed a lot of their issues with the operating system. When I first bought my Orange Pi, I was like, wow, this is really difficult to use. But it's definitely improved. I feel like heat throttling gets in the way less. You know, it's really difficult for me to gauge how much I'm earning from this one hard drive. I mean, it hasn't won any blocks. And if we look at our Creep Miner history, I've been keeping this for a few days. And this is just a screenshot. I accidentally, well, I didn't accidentally. I had to unplug the system in order to do this video. On the left-hand side, mined blocks. So you got over 1,000 mined blocks. This one was able to submit a deadline for a quarter of them. And the target deadline on this machine is 1 month. So that's not terrible. And this one block, I don't think this number is right. The pool that I'm using, which is pool.burstcoin.ro, they have like an 8% win rate, so this number is definitely wrong. I don't know why. Maybe I'm misinterpreting this, but yeah, who knows. Anyways, the lowest deadline, 2 hours, okay? And our average deadline, 16 days. What's really surprising is look at the lowest difficulty and the highest difficulty. Our network, our burst network, like difficulty is like shooting way up. I guess it's a good thing, but it is making it harder to win blocks, definitely. I am glad people are getting the burst, and you know, maybe my videos are helping people to do that and making it more difficult for me, but hey. On average, I think I'm getting about 150 bursts a day. You know, you do the math, it's about 3 bursts a day. So that means that 3 times 30, so one hard drive is churning about 90 bursts a month. Is that good or bad? I don't think that's a great number, but I'll definitely take it. But yeah, I don't think it's a great number. Yeah, this difficulty right now is just crazy. Let's move on to the experiments, the fun part. Let's safely disconnect this hard drive, okay? Because it's like right here and all over the place and stuff. So I want to safely, okay. And Haha, that's funny. I don't know how to unmount a thing. I forgot it was U-mount and not unmount. Goes to show you how often I use that command. Okay, so I can do the thing. Blink. Blink. Okay, so this is our regular drive. I'm going to put this over here. And we remembered nothing. Let's start. Okay, so here is our 16 KB drive. Let's plug her in. And okay, drive is online. And I got my little miner here. I'm gonna make sure it's warm and toasty. So you see, this is the error that I get when I mount a drive that I copied or plotted with Windows. It seems to be okay, but I have a feeling that if I try to plug this drive back into Windows, it's going to be like, help, I'm not formatted. So there's only 1 terabyte, it's like a 1.1 terabyte file in here, so it's going to be faster. What we're going to test is we're going to see if the average processing speed, probably not processing speed, average reading speed is faster or slower because the unit allocation size is different. And again, this is the 16 KB allocation size. So our read speed, according to Crete Miner, was 27.87 megabytes a second. And of course it processed it okay, because it's only 1 terabyte. What I wanted to do was use another utility for testing the read speed of a device. Using HD Parm. So we got 353 megabytes a second. And our buffered disk reads 98 megabytes and 3.04 seconds for 32.21 megabytes a second. So what I remember of USB 2 is its maximum operating speed is 480 megabits a second. And if you divide that out, that means that the theoretical maximum speed would be about 80 megabytes a second. So this doesn't hit even that. So this 32 megabytes a second is probably the maximum throughput this device can handle. You know, I had some comments about people saying, well, you're on USB 2, that's the problem. And you know what I have to say to that? Well, I don't think so. I don't think we're at the maximum USB 2.0 speed even. I mean, I could be totally wrong, but 480 megabits divided by 8 doesn't equal 32. So let's go ahead and run this one more time, because there's no blocks today. What in the world? Let's see what we get. So 2787. So now this is 2709. Okay. Hey, let's do it one more time. Okay. 2709, 2787. So we're about 27, what, 50? Okay, so our average actually just dropped a little bit more, where I get, I don't know, 27.3. Okay. I mean, it's still okay. We might actually have to run a whole bunch of tests to see like if there's any difference. If we run our HD Parm again, let's see if there's any noticeable difference here. No, the variance is very small. So I don't really see. Okay, so that's the result for this one. So let's go ahead and unmount this and let's try another one. Let's try the 64 KB. U-mount. Look, I can do it, guys. Media. Plug this guy in. Spam, spam, spam. There we go. I'm lazy. I could just type in mount. Okay, here. Yep, fix my disk. Windows is terrible, we know. You guys see that? That was 29. Look at that, 28. That's actually a little bit higher. Okay, let's do it again. This one came across lower. 28, 26.83. You know what? That's weird. Why is it so different? Did I spam it too hard? I feel like this number is higher though. What do you guys think? It feels like it starts off higher. Am I just going crazy? This number is still kind of low. The end number is still low, but that number definitely looks higher. It definitely looks faster. I mean, it's only by like a little tiny bit. And the read speed is not the bottleneck on this device. I'm not too concerned about that, but it is definitely reading it faster. Let's try our HD Parm test. That one was about the same. This one was about the same. That one was lower. You see that? That one was lower too. I'm so confused. What in the world? Oh, you know what? The miner is running. That's not fair. You're doing double the load. Okay, let's try this again. That's not a fair assessment if the miner is running. I still think it's not going to beat it. These numbers are lower. What in the world? And I'm actually going to power it off. Okay, it's powered off. Let's go. Let's plug it back in. Here we go. Okay. Crunch, 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 crunch. Hey, it's already back. What do you know? Mount. We don't have to mount it for our test, but for the sake of keeping the environment the same, let's make sure we do that. That's slower. That's slower. You know what, guys? I don't get it. What in the world? Now watch. We're gonna run the miner, and it is gonna be that marginally faster. There it goes. It went back up. See that? 28.5. Yeah. Yeah. Please. Computers, please. I'll run it one more time. That one was slower. And you know, the average speed here at the end is showing it's low. I don't know what to think about that. Because I'm not crazy, right? It is showing a higher number. See? 29, 28. Yeah, I don't know what to think. We might need to test this with more data. So that means another video. Maybe I'll run those tests on one of my other single board computers when I get those videos rolling. I think the result of my tests are this is inconclusive. We can't strongly prove either way that there is efficiency gain or anything like that by changing the unit allocation size during the formatting process. Let's plug in the original drive. Let's remind ourselves what it's like. Okay. Why are you blinking? Okay, so this is the 64 one. So the 64 one was the one that had suspiciously high numbers while it was mining, but the averages came out lower, which I don't get it. That doesn't make any sense. If you see mostly higher numbers, your average should be a mostly higher number. Yeah, I don't even know. I don't even know anymore, guys. Serious. These computers. You should just go outside and start digging holes. Did I plug in the right one? I don't think I plugged in the right one. Get out of here. I fooled you guys. There is actually 4 hard drives on the table. Dun, dun, dun. Okay, so we've got our original drive mounted. Just about here. Go, go. Okay, so I moved the file so I don't have to change my config. See, this number is high. You see that? It's in the 28s. It didn't hit 29, but it is high. I've seen this when I'm writing to the drive, where I'm doing sequential writes on the drive, and on Windows 10, I can see the graph. It starts pretty good, 150 or 180 megabytes a second write speed. And it just goes, and towards the end, it's about 95 megabytes a second write speed as it's getting to the outer edges of the disk. And I think we can see that sort of happened with the read speed too. And it might be the reason why the read speed kind of tends to fall off after the beginning. There could be some sort of technology that helps to increase the read of short reads from the drive. I'm not sure. But this one, 27.79 megabytes a second. The unit allocation on this drive is the 4K, so it's the default. Yeah, so I think the results of this experiment are very inconclusive. I'm actually beginning to think that the tests that I had put onto my 16 and my 64 KB unit allocation drives, it wasn't a sufficient size. But from the little that we can see, I think if there is a difference, it doesn't matter very much because there was no substantive results anywhere. But if there is a difference, then it favors the smaller unit allocation sizes. And I'm just trying to extrapolate what I'm seeing on the screen. Maybe you guys disagree. If you guys have theories or you know better than I or whatever, leave it in the comments and we can revisit this. But yeah, that's it. So, I mean, it was interesting. But yeah, I have nothing else to say. So, oh, I do have some tricks up my sleeve. So we're back to mining, right? Okay. So there was a couple of things that I was able to figure out when I was playing with my Orange Pi. If we go back into the Armbian monitor, the CPU core typically maintains its speed even when the system isn't mining. And these processors are designed to go into mobile devices, and mobile devices typically use a strategy for tuning the CPU when it's not being used. So when the device is, barely doing anything, the cycles per second drops, and when it's working really hard, they go up. It's the same system that is throttling the CPU when it gets too hot. And I think we'd see something very similar with, mobile devices, phones, smartphones, that kind of thing. Where, I'm sure it's happened to all of you. You plug it in and you're using your phone a lot, and it just starts to get really sluggish. This has happened to me. It's the same idea. I think it's the same system, which is saying, hey, you're too hot, you got to cool off. You can actually tell your system to use a strategy for changing the CPU around depending on the circumstances. So I'll close out the Armbian monitor here, and I'll put the command here in the thing. Oh my gosh, I can't learn how to copy and paste. Okay, so this is the command that I ran to make the CPU stay on. And this is going into the scaling governor. I'm going to change this to on demand. Okay. So what I was doing was I was telling the scaling governor to be on demand. So from what I understand, this is where the system will increase the cycles if it's under stress, and it will decrease the cycles if it's not doing any work. But in order for me to get that to work, I actually had to change the governor to power save, and that seemed to get it to start moving again. But anyways, you can see how the frequencies are adjusting here. And if I run the miner, it's going to push the frequency back up to 1200 megahertz when it's mining, and when it's not mining, it's going to adjust it back down. So again, it's the same mechanism that's doing the heat throttling. It's just another way the mechanism has an input and is adjusting the CPU frequency. So I found it kind of interesting. You could get a little bit of a speed increase by keeping your device on performance like I do. And that makes it so that the scaling governor doesn't have to compensate for when there's no work, and then suddenly there's work. it doesn't have to take time to increase the cycles that are going through the CPU. Now I'm curious. So let's see, this is almost 74. You see, a little bit of improvement, okay? That was totally unscientific. That's only one result. So with the scaling governor set to performance, you can get a little bit of a gain in speed. But besides that, I wasn't able to determine any other way using the existing system and software and not hacking anything too bad. I wasn't able to get any additional performance gain. I was, however, able to reduce the memory load on the system without impacting the software. I reduced the max buffer size from 400 megabytes to 200 megabytes, and everything seems to be okay. So I would recommend making that change. You can find that in the mining.config file. So I've got one more helpful little hint to help you guys set up your Orange Pi or your Raspberry Pi or Odroid Pi. Well, not really Pi, but set up your miners. And that is taking advantage of the built-in web server for CreepMiner. If you remember that screenshot from earlier, this one, you can monitor your CreepMiner from your local network pretty easily. And enabling that feature is pretty straightforward too. So if you remember the original installation directory, so for me it was my home directory. You can see we've got the CreepMiner directory there. What I did was I copied the public directory from CreepMiner/resources, and I put it in the same directory where I execute my run.sh, and that enables the web server. If you don't have it there and you try to browse to the web server, it'll redirect you to a login page and it'll be like, well, there's nothing here. So yeah, pretty easy to set up. I'll put the directions in the description of the video, and I'll also include the default URL for accessing the CreepMiner web interface as well. So that's it for today's video. Ended up being a little longer than I anticipated. I talked about a lot of different things, and well, I hope it was interesting enough. I'm gonna try to put out more than one video a week going forward, and I do have a lot of content that I'd like to talk about, but it does take a lot of time to make these videos. So with that said, if you do like my videos and you do like what I'm trying to do here and spreading the word of Burst, etc., use my links when you're buying things from Amazon or, you know, buying my recommended hardware, things like that. It really helps me out. Or if that's not an option for you, you can also send me some Burst or some Bitcoin. My addresses are in the description of the video, along with all the links to the products that I use. Usually in the description too, I give hints or whatever if I'm talking about Linux commands, blah, blah, blah. So anyways, I hope they're helpful for you. If you've got any feedback for me or you'd like to see something in the videos, just leave me a comment. Otherwise, that's it for this one, and I'll see you guys next time. Thanks for watching. I don't really like to talk about numbers and stuff on the video because, you know, it's not why I'm doing Burst. I'm not in Burst right now because I'm going to make a fortune overnight on it. I'm in Burst right now because I think it's the future. I think Burst is a great idea, and I mean, I could go on and on about this topic, but you know, I'm not in it to make money right now. I'm in it because I believe in this technology. Oh, what is this thing? Like, serious? My computer is freaking out. Look at this corner. Okay. Let's make this go away. Make this all go away. How do I'm gonna make this work. Watch. Okay.